All right, so we're going to start off with the math question here. It is an absolute value question. The absolute value of x to the power of 2 minus 6x plus 1 equals the absolute value of 3x plus 5 divided by 2. And you're supposed to solve for x. Apparently this person struggles with absolute values. And
absolute values are very tricky.
Actually, it looks like a pretty tricky one with the quadratic inside of it.
Yeah. So we're going to be solving absolute values and quadratics. Probably, possibly. We'll see how this one plays out. I will talk about really briefly. I've got the equation on my screen. I'm going to maybe make this a little bit. Actually, you know what? I'm going to write it out without the, it's really hard to type out and read math notation sometimes with our regular keyboard. So I am just going to write out the equation where it looks a little bit more normal. So the first thing I think we'll talk about absolute values first, just to have an idea of how they work, just because it seems like the person who is asking this question is having issues with the absolute value idea as well. So absolute value, what that means, and I guess we'll break that down first, is the distance from 0. So I was talking about distance. That even works in coordinate planes where we are two-dimensional. So we're same thing. We're talking absolute value is distance from the origin or from 0. So a very simple absolute value question, I'll kind of show you this, is be very simple here, is the absolute value of -3. What that means is what is the distance from 0 of -3? And you think on a number line, if I've got, here's my 0, -1, -3. -3 is 3 spaces away from 0, so the absolute value of -3 is 3, because it's 3 units away from 0. I'll give you an absolute value equation first, just to give you an idea of how this works. So let's say I had the absolute value of x is 3. So that means what number could x be that it's going to have a distance of 3 away from 0? And what happens with that is we know that we just saw that -3 has a distance of 3 away from 0, but there's also another value that has a distance of 3 from 0, and that is 3. So 3 is 1, 2, 3 spaces from 0. So absolute value equations often have two answers. We have the answer and then its opposite. So when we're solving more complicated equations like the one above, we need to consider that the absolute value of whatever we're solving for is going to be equal to whatever's on that side, but it's also going to be equal to the opposite of whatever's on that side. So we need to consider both situations. So when I go to solve this equation, I'm going to, as I mentioned, consider both. The first situation I will consider is just the regular without the bars, so that the fact that these two will they just will equal each other. The other situation, and I'm going to leave myself some space here, is that I need to consider that the absolute value of my first is going to equal the opposite of this. So make this negative as well, just like my 3 and -3 scenario. It equaled 3, but then it always also equaled the opposite of 3. So I have to consider both situations. So that means I'm going to leave some space down here. X squared minus 6x plus 1 is equal to, and I'm going to negate everything on this side. So do the opposite of that. Again, this is just like what I did over here. So I have two equations that I need to solve for, and I'm going to have two solutions. So going from there, I'm going to go ahead and set this equal to 0. This is a quadratic equation. I'm not going to really get into depth, and my class does quadratic equations for a whole month on how to solve them, so I'm not going to get too in depth on I guess the theories of solving them and the methods of solving them, but the way that we're going to use today, it looks like, because our numbers are kind of messy, is the quadratic formula. And the quadratic formula requires you to get your equation to look like this. make it equal 0 in general form. So that's what I'm going to start out doing, is I'm going to make my equation equal to 0 by subtracting 3x from both sides. So that gets me closer to 0. I have negative 9x over here. And again, I'm not getting really into the nitty-gritty of how to or why this is, but so I'm going to change this 5/2. I'm going to change that into 2.5, just because it's maybe a nicer, easier number to work with a little bit. Depends on your thoughts on fractions. And then we're going to say that this is x squared minus 9x minus, minus 1.5 is equal to 0. So from here, I'm going to need to do the quadratic formula. I'm going to save that, though, because we'll do that together with both of them. So I'll save that, and then we'll do the same over here. We'll get it so that I can get it ready to do the quadratic formula. All I'm doing, again, is I'm getting it in this. This is called general form, set equal to 0. So I'm going to do that with my second equation. So I've got, over on the right-hand side, what I want to do is I want to distribute this negative sign. And that will end up getting us negative 3x and negative 5/2. And let's go ahead and change that to 2.5. Negative 2.5. And then over here, I still have the same. I didn't do anything with that. And then same thing, I'm going to make this equal to 0 by doing the opposite on my right. I'm going to say plus 3x on both sides. Oops, gosh. And then plus 3x on this side. So then over here now I have x squared minus 3x plus 1 equals negative 2.5. And then same deal, I'm going to go ahead and do the opposite here. So plus 2.5 plus 2.5. So I end up having x squared minus 3x plus 3.5 is equal to 0. So these are my two equations that I'm going to need to use the quadratic formula with. So all I did really in between these two steps is I did a lot of algebra to make it into general form. And I've got two equations that I still have to solve here. So in a separate tab, I'm going to show you what the quadratic formula is. Let me maybe explain it briefly. So if an equation is written like this in general form, and I've had students try to do this a lot, try to isolate x. Usually that's our theory when we're trying to solve equations. Well, you might notice there are two terms with an x in it, with a variable in it. And so that makes it very difficult to isolate it. It's possible, but it's difficult. And so what the quadratic formula is all of the steps were taken to isolate that x with our equation in general form. And here's what happened. We got this. Negative b plus or minus b squared minus 4ac all over 2a. That's if I did all of the steps to isolate x in this equation up top, I would come out with this. And so what we do is we use that quadratic formula almost as like a shortcut. Let's not do all those steps to isolate x. Let's just plug in our coefficients a, b, and c since somebody solved it for us. So back to, oh man, let's see if I can get there easily. There are a lot. We don't delete our stuff here. So I need to get to, oh my gosh, I need to get to 50. So my first one was x squared minus 9x minus 1.5. So let's go back to, oh gosh, wrong one. 51 minus 9x minus 1.5 equals 0. So here's how this works. And I might just run it with this one for time's sake and not the other because it works the same way and you just are going to watch me doing the same thing. I might leave some work to you guys, actually. But here's how it works, is we're going to start by identifying our a, b, and c coefficients. So a, b, and c. So our a here is actually kind of hidden. And when it's not written like that, it's understood that it's a 1. Our b here is negative 9, and don't forget to take the signs with it. It's a common issue. And then our c is negative 1.5. And so negative 1.5. And so all I do at this point is I plug in. I just replace. I replace my variables. I'm going to say x is equal to negative b, so negative negative 9, that's my b, plus or minus square root of b squared, so negative 9 squared, minus 4 times a, which is 1, and times c, which is negative 1.5. And that's going to be all over 2 times a, which is 1. And then from here, we just have to simplify. I know, again, this seems like it's a lot of steps. It's not really terribly difficult, but it's a lot of steps. So I've got negative 9, which is now going to be positive 9, plus or minus. And then I have negative 9 squared, which is 81. And then minus 4 times 1 times 1.5. So we get positive 6 over 2. And just continuing that on, I have 9 plus or minus the square root of 87, which is not a nice one, over 2. This is where I'm going to grab my handy dandy calculator because the square root of 87 is not super nice number. And we're going to estimate at this point. So I've got 9 plus or minus, and the square root of 87 was 9.327 over 2. Now I'm going to have two answers for this. So I have 9 plus 9.327, and then divide that by 2, which gives me, so 9 plus 9.327 divided by 2 is going to give me 9.163. And then I also have to do 9 minus 9.327 divided by 2. So 9, I want to get an accurate answer here. Square root of 87, and then divided by 2. So then we get negative 0.164. So these are two solutions. There will be two other solutions as well. Let me go back to the page. I'll just show you this. I'm not going to go through it again. But those were the two solutions to this part of the equation. There will be two more solutions to this part of the equation, but you solve that one the same way that I just did the other one with the quadratic formula. I'm not going to run through it because I don't think you need to watch it. In fact, I just think that you need to practice. So that is how to solve that problem. Big idea though, remember for absolute values, you have two parts of your equation. You want to set it to the positive, and you want to also set it equal to the negative, or the opposite, because of the way absolute value works.
Seemed pretty simple and straightforward.
Yeah, no big deal. No big deal.
Yeah, that was epic, but really well done.
That was a pretty epic problem.
I think that might be the first problem that anybody's used two tabs on.
I know, I realized I'm like, this is going to be, this
two-tabber.
is just too much.
Oh, an old two-tabber.
Woo. But we did it. That's what we're here for.